So hello everybody, we are dealing with a very interesting problem. The problem is stating if there are n charge carriers per unit volume and all are moving with the same velocity vector u as shown in the diagram, each carrying a charge q. If the frame is of area A, then calculate the average current through the frame. So obviously the formula which we know of is I is equal to NEAV, where V is the drift velocity, A is the cross sectional area. So whenever we are using this formulation, so this formulation is applicable when the cross sectional area A and drift velocity V is such that the charge particles are moving perpendicular to the cross sectional area. That is, if we consider the conductor to be like this, so if we consider a cylindrical container or a conductor, then we consider that if this is the cross sectional area A vector, then the drift velocity of the charge carriers is also like this, that is in the direction of A. So this is the drift velocity direction. But in the given problem, u vector and a vector are not parallel to each other. They are making a certain angle with each other. So u vector and a vector are not parallel to each other, but they are making a certain angle with each other. So over here we can say that the equation of current will change. In order to evaluate this, let us reconsider the following diagram. So this is the original scenario which we have, where each charge carrier, each having a charge q, is moving with a velocity v through an area A, where the area vector is like this, that is area vector is making a certain angle with the velocity vector. So if we consider a prism through which these charge particles are passing in a time interval delta t, so in a time interval delta t, they will cover a distance u delta t. So this volume of the charged particles will be crossing through this area. So over here we can say that the number of charged particles which will be crossing through this volume, so number of charged particles, so capital N can be written as N into volume of the prism. So where volume of the prism we are writing it as base into altitude, so over here we are writing it as A dot u delta t. So this is the core aspect of the problem. So for area we are using capital A. So we are writing it as n into A vector and then u delta t. So over here if we write the expression for charge, so the average current which is passing through this area, so each charge is having a charge q and total number of charge is n, passing through an area A in time interval delta t. So the average value of current over here will turn out to be a small n q A dot u, A dot u, or we can also write it as I equal to n q A u cos theta, where theta is the angle between A vector and u vector. So although this concept is not something which is not many students know of, but it is very important over here that in the textbook generally we have this aspect where I is equal to NEAV, and if a problem like this is asked where the cross section area and velocity vector is making a certain angle, then it can create a little ripple in the head of a student. So for such problems we are using this condition. So this problem originated in the textbook of Berkeley's physics course, and it is authored by Edward M. Purcell. So we are using this textbook for this context of this problem, and I think it was a relevant one. So please keep in mind that whenever you are using this formula I equal to NEAV, this is the condition which is necessary where V vector and A vector are parallel to each other. If V and A are making a certain angle with each other and a certain area is given to us, then we deal with it in this way, that we write it as NQ A dot u. So this is the vector form of the expression which we use for NEAV. where v is drift velocity. So for more such videos, continue to watch the channel. Please like, share and subscribe for more.